So we have a pretty interesting problem here. We have a ball that's dropped from height of 10 feet, and each time it rebounds to 2/3 of its height before. So a couple questions we might ask about that. So how many bounces until it goes up only 6 inches or less than 6 inches, let's say? And what's the total distance covered? So let's think about what happens. So it gets dropped from 10 feet, then it bounces, and it goes up to only 2/3 of that and goes back down. Bounces 2/3 of that, so on and so forth. So when it first falls, it covers 10 feet. Then it bounces back up and it does 2/3 of that. Then it comes back down, of the 10 feet. When it comes back down, it does 2/3 of 10 feet again. Then it goes back up and it does 2/3 of the 2/3 of 10 feet, and then down it does the 2/3 of the 2/3 of 10 feet again. And so what you can see is we actually have a geometric sequence. So the height on the first bounce is 10. Second bounce is 2/3 times 10. Third bounce is 2/3 squared times 10, and so on. So we have a common ratio of 2/3. So A sub n is going to equal how high we go on our first bounce. So 10 to the 2/3 times n minus 1. Now let's see, how do we want to, let's do it to the n, because when we have no bounces it's 10. At one bounce it's 10 times 2/3. So this will give us basically the height of any given bounce. We want to know when it's going to be less than 6 inches, so let's find out when it's going to be 6 inches, how many bounces. So 10 times 2/3 to the n equals, we're not going to put in 6 because we're doing this in feet, equals 1/2. So we're solving an exponential equation. So we can divide both sides by 10, and we get 2/3 to the n equals 1/20. Let's solve this using our logs. So log of both sides, because that allows us to pull the n out front. And we're going to get the number of bounces to be exactly 6 inches is log of 1/20 over log of 2/3. Let's see what we get with this. So this is something you want to be careful how you put it into your calculator. I know it's not easy to see my calculator, but let's put it up here. I'm going to make sure you use the right parentheses. Log of 1 divided by 20 divided by log of 2 divided by 3. So we get that this is about 7.4. So what that tells us is on the 7th bounce, it's not quite, it's still a little more than 6 inches. So, and 8 bounces, it's going to be less than 6 inches. So that's how we can handle that. Now we need to think about the total distance traveled. What we mean by that, it goes 10 feet down, then 2/3 of 10 feet up, then 2/3 of 10 feet down. So we're actually going to sum up the terms of our sequence for this. So let's get a little bit more space. I'm going to use something we did here. Sorry, I bumped my camera there. So right here, I had started doing the bounces. So that was drop. That was first bounce up, down, up, down. So if we look at the pattern here, 10 feet for down plus, now this one, notice I basically have 2 of them, so 2 times 2/3 times 10. because one's for up and one's for down. Plus 2 times 2/3 squared times 10. Again, one's for up, one's for down, and so on and so forth. So what we have is we have a geometric series. Now the whole thing may not be geometric because of the 2. This one didn't get doubled. So what I'm going to do is I'm going to split it. So I'm going to have the 10 separate, and I want to see if I can look at this as a geometric series. Well, notice I have a common ratio of 2/3 again, and so I have 2/3 to the n, and now my first term is not just going to be 10, it's actually going to be 20. So that's where it kind of breaks from the pattern, and we don't want to include the first term, but every other term we can. Now here, notice that it starts at 2/3 to the first, so I'm going to start it at n equals 1. And we want the total distance traveled, so we want to measure this thing as it goes to infinity. So we have 10 plus an infinite geometric series. Well, we can do the sum of an infinite geometric series. Remember that the sum is equal to the first term over 1 minus the common ratio. So our total distance traveled will be 10 plus the first term. So if I plug in 1, I get 20 times 2/3. This is all over 1 minus our common ratio of 2/3. So now we don't really need that one anymore. We know we're doing the total distance traveled. Okay, so we have 10 plus 20 times 2/3 over 1/3, which is equal to 10. We're going to flip and multiply, plus 20 times 2/3 times 3. This works out pretty nice. These 3's cancel. So we have 10 plus 20 times 2, or when all is said and done, the ball going up and down is going to travel a total of 50 feet. So that's how we can apply an infinite geometric series to solve this problem.